Good afternoon to all of you. In the last session, we have seen the different types of fuels, solid, liquid, and gaseous. We have seen what is meant by higher heating value, what is meant by lower heating value. Okay. We have seen the applications of the combustions in the engineering applications. Now, in today's session, okay, we are going to see the properties of liquid fuels. The properties of these liquid fuels plays a very important role in designing the combustion appliances. Now, the first important property is specific gravity. Specific gravity is ratio of mass density of fuel to mass density of water at the same temperature. So what is the standard temperature? We take the standard temperature for fuel and water as 298.8 Kelvin. Now there is one more that is called as American Petroleum Institute scale, API scale. This API scale also corresponds to specific gravity. But in order to determine the API scale, there is a modified formula. And when we have to use this API scale, we must know the specific gravity of the fuel. Now, the API-SG, we called it API specific gravity. Now, this formula is given as 141.5 divided by specific gravity minus 131.4. Now, see this one, the formula here of API-SG consists of the constant and the specific gravity. So, you may have the question, why we cannot use the specific gravity instead of API-SG? The answer to this question is, this API-SG is related with higher heating values. Okay, now see here, there is a relationship between API-SG and higher heating value. For gasoline, the higher heating value is given as lower heating value LHV plus 93 in bracket API-SG minus 10. So if you know the value of API-SG and lower heating value, you can get the value of higher heating value of the fuel. So next important property is the auto ignition temperature. The auto ignition temperature is the lowest temperature which is required to make the combustion self-sustained without any external aid. So what happens when there is an auto ignition? When there is a spark, and that spark is responsible for the ignition of the fuel. And when the fuel molecules ignite, they produce certain amount of heat, and this heat propagates the combustion. Okay, so after there is a spark, there is a propagation of the combustion. Okay, and there is no other external means required to sustain the temperature. So to sustain the combustion. The combustion will go on in its self-sustained manner. So this we call as the auto ignition temperature. Okay, so this is a very important property. Now, the next important property of the fuel is the flash point. The flash point indicates the minimum temperature at which the liquid fuel will produce sufficient vapors to form a flammable mixture with air. Okay. Now, what is the significance of this flash point? So, the temperature at which the liquid fuel will form the vapors. So it will form the vapors, but it will not ignite. Okay. And some more temperature is required when it forms vapor. Some more heat is required, some more temperature is required, then the fuel will get ignited. So the flash point indicates it is the maximum temperature at which we can store the fuel without any fire hazard, or it is a beyond that point we should not go. It is an indicator that if the temperature go beyond this point, there will be the probability or the possibility of forming the vapors. Now the next important point is the fire point. And the fire point is the minimum temperature at which liquid fuel produces sufficient vapors to form a flammable mixture with air that continuously supports combustion, establishing flame instead of just flashing. So this is the temperature at which there is the vapor formation, and this vapor mixes with the air, that is the oxidizer, and it continuously starts the combustion process. Okay. So this indicates the fire point. Now the smoke point is the point at which there is a tendency of the fuel to produce the soot. Soot can be the, we can say, ash. Okay. Now next is the cloud point. The cloud point is the temperature at which wax crystals starts forming from the fuel when it is cooled. So as the temperature goes down, okay, then certain waxes are present in the fuel. This starts to form. Okay, and due to this, the viscosity of the fuel increases. Okay, and it is very difficult to burn this fuel. Okay, so that temperature we call as a cloud point. Now we can see here there are different types of these liquid fuels. The first one is the automotive gasoline, that is nothing but the petrol. Second one is the diesel fuel. Third one is the methanol. Fourth one is the kerosene. And this is the ATF. This full form of ATF is aviation turbine fuel, and we may call it as a JP8. Okay, so there are different categories such as JP8, JP10, okay, as per the properties. Now the first important property is the specific gravity, or we call as a kinematic viscosity, and the reference temperature we have taken for this is 293 degree Kelvin. Okay, now here the specific gravity of this fuel. Okay, now what is it is 0.72 to 0.78. Okay, so we can relate it if this is, we know what is the gravity, the specific gravity of this water. It is 1000. Okay, 1000 what? It is 1000 for 1 kg of water, 1 liter of this water. Means it is 1000 grams for 1 liter. Okay, so here it indicates around 0.72 for 1 liter of this gasoline. 1 liter of this gasoline will give is 720 grams. Okay, so we can relate with this. Okay, now here we can see the diesel fuels and these kerosenes have more amount of the specific gravity. Then next is the kinematic viscosity. It is a very important property. If the fuel is having a very high viscosity, then it is very difficult to atomize this fuel. Okay, therefore we should have the kinematic viscosity in a very low amount. So we can atomize this fuel. The next is the boiling point range. Okay, so when this boils, okay, or forms the vapors, that is these temperatures. Okay, here we can see the lowest range is for this atom to gasolines. Flash point. Okay, so this is the flash point at which it forms the vapor. Here you can also see for the petrol, the flash point is lowest. Next is the auto ignition temperature. So here if you compare this, the auto ignition temperature for the kerosene is the lowest. Okay. And next is the stoichiometric air fuel by mass. Okay. So here we can see here the air and fuel ratio by mass. In this case is the lowest for the methanol. Then the heat of vaporization means amount of heat which is formed by burning of 1 kg of fuel. Okay, so it is highest in case of this methanol and lowest in this kerosene. And what is the lower heating value? LHV. Okay, so the lower heating value is we can see lowest in case of this methanol and it is highest in case of this kerosenes. Okay, so more or a very large amount of heat is produced by this kerosene per kg of this fuel. Okay, now what are the different types of solid fuels and oxidizers? Okay, now solid fuels. Okay, the solid fuels consist of different constituents. So one of the major constituents we know what that is the carbon. But along with carbon, there is a hydrogen, ash, nitrogen, oxygen, and sulfur water. Okay. Now there are different types of solid fuels. There is a wood, coal, charcoal, soft coke, biomass, animal dung, animal that is cow dung. Okay, then propellant. Okay. Now these solid fuels are designated with some chemical formula. And this chemical formula comprises this C for carbon, H for hydrogen, and O for oxygen. Okay, so here the number of this carbon, hydrogen atoms, okay, in these molecules determines its what is the calorific value. Okay, so if we consider this as a Reich's Hughes, okay, we get hydrogen as 1.78 and AM as 0.56. Sawdust, we get here the N value as 1.65 and 0.69. Okay, so if we compare these values, okay, we can get the chemical formula for these different fuels. Okay, now the next is uh, solid fuels and their oxidizers. Okay, now here biomass. The biomass is the wood, sawdust, rice husks, rice straw, or the wheat straw. Okay, so these are nothing but we get from the our farms. We call them as a biomass. This biomass is a we can say very important in rural lives. People in rural India till today use this as a source of fuel. Okay, now if you go in rural here in our rural villages, some people use this biomass as the fodder for the animals. Okay, the after harvesting, whatever the wheat hugs or that is we are getting, it is given for the uh, fodder for the these cows. Okay, and some people use this as per their need. Okay, now the oxidizer which is used in the biomass can be our air. and the application is here in our domestic use. Then next is the coal coke or charcoal. Okay, they also require air as an oxidizer, and this can be used in the different applications for the power generation purposes. Then there are the special fuels, that is a nitrocellulose, we call this a NC, STBP and CTBP. So these are used in the solid propellant for rockets, okay, or the hybrid rockets. In this, we are not using this air as oxidizer. In this, we use special oxidizers. We call this as a nitroglycerin, ammonium perchlorate, ammonium nitrate, and nitrogen tetroxide. Now next is the oxygen, water, and ash content of certain solid fuels. Okay. Now the moisture in the solid fuels. Okay, this can be in the free form or in the bound form. Okay, fuel moisture content will affect the rate of combustion and the overall efficiency. Next is the ash. This ash is the inorganic material which remain as a residue even after the complete combustion. Now, the ash content affects the performance of the combustion systems. Ash content of the coal causes fouling of the boilers. Okay, so what is meant by fouling? The fouling is, we can say, a it is a accumulation of the uh, accumulation of the soot particles or the ash particles on the tubes of the boilers, which affects in reduction in the heat conduction. Okay. Now, what are the fuels? Oxygen and moisture and ash. Okay. Now for the fuel, okay, if you see the wood, peat, lignite coal, bituminous coal, and anthracite coal. Okay. If you see what is the oxygen, moisture, and ash. For the wood, the oxygen is in range of 40 to 45%. Moisture is in 15 to 7%, and dry ash is 0.1 to 1.0%. Okay, so here peat. Peat is a form of coal. Okay, here we can get moisture in a very high amount, that is 70 to 90%. Lignite coal, in this we can get uh, moisture in between 20 to 30%. It is more, we can say, the good coal as compared to peat type of a coal. Bituminous coal is again a high grade form of a coal in which the ash content and ash content is high. Okay, but the moisture content is very low, that is around 10 to 5% only. The anthracite coal, which is a very high grade coal, here the moisture content is very low. Okay, it is around 2 to 4% only. Okay. Now, the next important thing is the characterization of the solid fuel. So what is meant by the characterization? In which the characterization is a process in which the fuel are studied, the properties of the fuels are studied. Okay, they are analyzed, okay, for their practical use. Now here the first important property is the proximate analysis. The proximate analysis is used to determine the moisture content, volatile matter, fixed carbon, and ash content in the solid fuel. Now, to determine this proximity analysis, we have few grams of fuel and which is heated around 378 degree Kelvin, okay, till it attains a constant weight. Okay, so when the fuel is heated at around 100 degrees centigrade, okay, then what is going to happen? That all the water content of the fuel will go around, means what will be the water or moisture that will be taken, and the mass of the fuel of this after some time the mass of this fuel will remain constant. It will no longer change even though we are adding heat to that. Okay, so this indicates, okay, all that water particles are evaporated. And next is the volatile matter. And this, to determine this volatile matter, we have to heat this sample at 1200 degrees centigrade. Okay. Then next is the ultimate analysis. And the ultimate analysis is very much important in order to get the elemental composition of the solid fuel. Okay. Now in this case, what is the nitrogen content in the fuel? We are determining using the chemical method. Then what is the sulfur? The sulfur content is evaluated by burning the fuel to convert it into SO4 followed by precipitation method. And next is the what is the calorific value, that is determined by using the bomb calorimeter. Then next is various combustion modes. Okay. Now here there are the different types of combustion mode, that is a flame mode and the flameless mode. We called it small daring. Okay, so flameless mode, we can get the example of the cigarette. When you are using this cigarette, I do not recommend that you should smoke, you should use the cigarette, but I am giving here the example. If you do not take it in the other way, when we are lighting the cigarette is burning, there is a combustion, but that combustion is a flameless combustion. Coal, the coal, we cannot see the flame, but it is burning. We can see the shininess, the redness, and we can determine the burning of this coal. So this one is the flameless combustion category. Now next is the flame mode. Okay, in the flame mode, there are two types. One is the premix flame and next is the diffusion flame. Okay, so what is this premix flame? The fuel and oxidizer are mixed before the actual combustion. Okay, so the example is a Bunsen burner and the LPG stove. And the diffusion flame is the fuel and oxidizer are mixed in the region where the chemical reaction take place. Okay, now if you see the difference between the premix flame and the diffusion flame, I can give you the simple example. The premix flame corresponds for a low marriage. Okay, what happens in the low marriage? The both bride and groom know before the marriage. Okay, and in the arranged marriage, what happens? The there is a certain procedure, and after that the marriage takes place. So this we call as a diffusion flame. Okay, so next is the laminar and the turbulent flames. Now after the combustion, based on the flow characteristics, the turbulent flow occurs in the practical combustion devices. Okay, so when there is a candle, the flame of the candle we can see in the laminars. Whereas when we are doing a combustion which is in the uncontrolled manner, we can see the turbulent flames. Now the next one is the important, that is we call as a environmental pollution. Now the combustion of any fuel produces certain amount of emission such as smoke, ash, soot and other harmful gases. The major pollution generated in combustion systems are CO, CO2, NO, NO2, SO2, okay, then ash. Some of these are caused due to the incomplete combustion, and it can be minimized by increasing the residence times of the fuel oxidizer mixture in the combustor. Now, in order to reduce the environmental pollutions, certain norms are implemented by the central agencies, okay, that are in India, Europe, and China. In India, we are using different norms. Here we have implemented the BS1 norms in 2000, that is the nationwide. This BS1 norms corresponds to Euro 3 norms. Okay. Then in 2005, we have implemented BS2 norms nationwide. Okay. Now this corresponds to Eurofoam norms. Okay. In China, in 2004, they have put China 2 norms, and in 2007, they have put China 3 norms. Then in 2010s, we have implemented BS3 norms nationwide, which corresponds to this Euro 5 norms. Okay, and in 2011, the China has uh, given the China 4 norms. Then in 2015, okay, we have implemented BS4 norms in the major cities. Okay, now here this corresponds to Euro 6 norms. Okay, now in 2018, okay, the China implemented BS5 norms the nationwide. Okay, now in 2020 and 2019, okay, we have the BS5 norms nationwide. Okay, and in 2021, the BS6 norms are implemented nationwide. Okay, now in this case, we can see the proposed timeline in Indian Auto Fuel Vision and Policy of 225, published in 2014. Okay, now the direct transition from BS4 to BS6 by 2020, the intent declared by the Ministry of the Road Transport and Highway in January 2016. Okay, now in 2024, okay, there will be the compulsion of the BS6 nationwide. Okay, now the emission from the different sources. Okay, so now here energy emissions and non-energy emissions, we categorize emissions by these two broad categories. Now in energy emissions, we get power is a very high, which corresponds to 24% of total emissions. Then next is 14%, that is the transports, 8% is buildings, 14% is the industries, then 5% is other energy related, 3% is the waste, 14% is the agriculture, and 18% is the land use. Okay, now these are the major contributors of the pollutions. The data is from 2010. Okay, now the next is by 2014, the global CO2 emissions from fossil fuel combustions and other industrial processes. The CO2, we call this as a greenhouse gas, and it is very harmful, and this is responsible for the global warming or the climate change. Here, India is having only 7% of CO2 emissions, whereas the China is having 30% and United States 15%. And the European Union, of comprising of 28 nations, is of 9%. Japan is 4%, the Russian Federation is only 5%, and the other rest of the other 30%. So this is the overall picture of the CO2 emissions. Okay, so now today we will stop over here. The next lecture will be scheduled, and the link for the next lecture will be posted on your WhatsApp group. I hope all of you should see this lecture. Okay, and if you find any doubt, you can message me on our WhatsApp group. So thank you for today.